Okay, good evening. Today I'm with a new look. Uh, just give me a moment. Okay, so we had done several videos on center of mass, and I had a few viewers who asked me about they need some revision about it because every problem seems to be quite unique, and we need to know what is it we have learned. Can you just summarize it? Okay, so I thought maybe we can do a revision for today's video, and then we'll proceed further. Okay, so towards it, we have done so far 5 different videos. The first video was on how to find the center of mass in a set of particle arranged in a given geometry. The second video was on the finding out the center of mass on a stacked object. That means if I stack several objects, okay, of different geometries, different sizes, and in that case, how do you find the center of mass? The third video was on finding out the center of mass of melting ice in case of a gravity-free environment. The fourth video was on finding out the speed of the boat using center of mass. Okay, where we can use this. And here also we assume center of mass to be zero. Hey, one common thing that you can find in all these videos is I never consider center of mass to be in motion. Right? See, center of mass is not moving here. Center of mass is not moving here. I assume it's static over here. Because the objects did not move. Okay, so here also the object melted, but the water molecules started moving. But since there was no gravity, it was not moving downwards, and hence center of mass remains in the same position. And so there is no velocity here. So here you see that the two objects started moving over here, the man and the boat, but still center of mass did not change. Center of mass are assumed to be a constant over here. Okay, I got a question based on this also. And here also, if you see, there were two objects, M1 and M2, connected with a spring. And then what happened was we stretched it by a distance x naught. And then the moment I left it, okay, so both of them came closer. So here also center of mass, there was no change in center of mass. So someone interestingly asked me this question, sir, is it that the center of mass will never move? Center of mass is always seen to be a constant or what? Okay. So this was an interesting question. So we have not seen or we have not gone through any problems which shows or which depicts how the center of mass moves. Okay. The question would be very relevant when we discuss about usually in textbooks we look at problems which are related to rotation. But today what I thought was let me revise all this and also give an insight on how the speed of center of mass changes. Okay. So towards it, now let us take up an object of mass m. We already revised it. I'm just going into a little bit detail. So the focus here is more on the velocity of center of mass. Okay, the same question I'm going to address. Because the rest of the videos that I'm going to make will be dependent on the velocity or speed of center of mass. Okay, I have an object of mass m. I'm giving a push here. It's having a velocity v. Let us say the friction here is 0. Now what will happen? What do you think will happen? This object will keep on moving like this, right? Okay, so as a result of this, so this is similar to that of something like this. I thought of adding an animation over here. Somebody also asked me, sir, your videos has something like only text. Okay, why can't we have something like animations, some colorful pictures and so on? So I thought, okay, so whatever is available, I can just put it across. So most of the time I feel like teaching using writing, okay, instead of putting it across animations, because I always think that writing and then learning is more easier. Okay, so now I have an object which is moving like this. Now it has a velocity v here. Now where is the center of mass? Now, some of them say that okay, center of mass is nothing but if you want to find the value of center of mass, we know that center of mass is given by xcm because it's moving along the x-axis. Xcm is equal to m1 x1 plus m2 x2 plus etc divided by m1 plus m2 plus etc until mn masses. So if I consider one mass here, I have another mass here, another mass here, third mass here, fourth mass here, so on. Okay, I consider this as my origin. This is my origin. Hey, don't run faster. Okay, this is my origin. Okay. So as a result of this, you see these masses are not moving up and down over here. It's moving only in this direction. So I can now say x1, x2 coordinates are all known. Okay, m1, m2 are all known. Can I just find out using this method? This was one question, one more question, which was asked. Okay, I will get the value of center of mass. What will be the center of mass? See, x1, x2, x3 are not changing over here, so it should remain the same. But how do I find out the center of mass velocity? That's the question. If you are aware of the differentiation, okay, so calculus part, then we know that dx by dt will give you the velocity. If you already calculated center of mass using this expression is right. You can use it for this. Okay, and then what you do is you find out dx by dt. Now, in this case, as you see, the object appears to be moving. So the position of this object with respect to time seems to be changing. So as a result of it, you find out how much does the position change with respect to time. Are you right? If you're not aware of the dx by dt, you can just say delta x by delta t. What is delta x? Change in position. What is delta t? Change in time. Okay. Take the ratio of these two, which is distance by time. How much distance the object has traveled in a given unit of time. You can easily find out, and thus you get the center of mass. Right? So center of mass of the object is nothing but what? The speed of the object itself. Okay, in this case. So this is true whenever the object is sliding. Remember, I'm talking about sliding. I'm not talking about rolling. Okay, there's a difference between these two. So we'll come back to it later. When the object is sliding like this or like this, then definitely the center of mass velocity is equal to the object's velocity. Let us look one more animation. Now you see, I have an object which is in this form and it's been thrown here. The object now falls down like this. Now when it falls down here, where is the center of mass? Now you see, it falls on a particular curve. Now, this is a big object. See, this has a larger mass over here. This is a larger mass over here. This has a smaller mass over here, connected by a rod over here. Definitely, wherever the object has a larger mass, where is it? It's here. Wherever the object has a larger mass, then the center of mass will lie nearby to it. Okay, that's what has been seen. Okay, and that is the reason why it has also been powered over here. It's been kicked over here. It's been thrown over here. So as a result of it, you give a force at the center of mass, the object does not change its orientation. See, it does not bend like this, right? It just goes like it over here. Suppose if the shooting gun was placed at this point and it has been shot here, definitely the object would have rolled like this and would have fallen. Okay. So there is a motion of the center of mass. And here also we observe that the motion of the center of mass, the position of center of mass does not change as the object keeps on falling. Okay, you can say even the speed of the object and the center of mass position does not change. Okay, let us take up one more example. Now let us look at this point. See, the position of the center of mass in this case is always same. See, at this point over here. As the object keeps on going like this, okay, he throws the object like this, and you see the bottle keeps on rolling, or maybe the stick, or whatever you call this. Okay, it keeps on rolling like this, and finally it falls over here. So thus you see there is a motion of the object. And usually, whenever we throw something like this, what do we say? We say that we will ascertain or we will approximate this to be a point object. Now, what do you mean by the point object? That means the entire mass is being focused at the center. So, in all these three cases, what I have done is I have taken an extended object. Okay. When I take an extended object, then I have asked a question, can I approximate it to one point object? Of course, I have done it. What I have done is I have considered an extended object and I approximated it to the point object. Okay, when I approximated to point object, I see to it that the center of mass moves with a velocity which is equal to the velocity of the object. See, in this case, what's happening? It's rolling and also moving. See, this point, if you consider, say similar to it. See here, for example, there's a perfect translation. So here there's a rotation. See, there's a rotation. It throws it up like this, and as a result of it, it rotates like this. It rotates like this. See, it rotates like this. It goes like this. So this end keeps on rotating like this. This end keeps on rotating like this. See, if this is the object, it keeps on rotating like this. It keeps on rotating like this, and so on. It goes like this, right? So therefore, so every point on this object has a different velocity, but this point only has one velocity or one speed. So this is nothing but your center of mass speed. Okay. So thus you can see center of mass also can have a velocity. With this, I will stop for today's talk. I'm not going to extend it beyond this. The reason is because we know that if I extend it, the video would go for longer. People will lose interest. So let me consider with this the next talk about how to arrive at the center of mass, speed or center of mass velocity. Thank you, friends, for watching. If you like this video, do share and comment. And if you have any doubts, do contact me and subscribe to my channel for more updates. Thank you.